Module 3. Using the SensorTile.box PRO in entry mode. In this module, we will get familiar with the SensorTile.box PRO and the STBLE sensor mobile application. We'll look at the default configuration of the sensor tile, we'll see the entry mode applications available for use, and we'll program our first application configuration to the board. For this workshop, we'll be using the STBLE sensor mobile application to interact with the sensor tile. This mobile application enables wireless communication over Bluetooth Low Energy, or BLE, with the firmware running on the sensor tile. The app supports sensor data reception and command transmission over BLE and is compatible with many of ST's evaluation boards and software packages. To get started, please make sure you have installed the STBLE sensor mobile application from the Google Play Store onto your Android device. Please note that you may see two applications shown in the Play Store if you search for this. One is titled STBLE Sensor, and the other is STBLE Sensor Classic. Today we are using the STBLE Sensor application, not the older Classic version. This is the latest supported application, and is where all new features will be added in the future. Feel free to pause this video now to give yourself time to install this app if you have not already done so. Let's start by seeing how the sensor tile works out of the box. First, turn on the sensor tile by using the power switch on the side of the box. Note that your sensor tile does not need to be plugged into your PC via USB, since it can be powered by the onboard 480 mAh battery. If you are turning on your sensor tile for the first time, it should have come with at least a partial charge that should be enough to get you through this portion of the workshop. However, if your board does not power on, it's possible the battery does not have enough charge. In this case, please connect your board to your PC using a USB Type-C cable. Once you have powered on your board, you should see all of the LEDs cycle rapidly, then turn off, and after a couple of seconds, the green LED will turn on and stay illuminated. It's now ready for you to connect via the mobile app. Launch the STBLE Sensors app. If this is the first time you've launched the app, you will be presented with a license agreement. Please read and accept this to continue. Next, you'll be given a brief overview of the app. Swipe through each screen and then tap Close when finished. Now the app will ask you about your level of experience. Go ahead and choose I am an expert and tap Next. When asked to define your interest, please choose Firmware Developer and then tap Done. This will unlock all features of the app that we will use in this workshop. The app will now ask for a variety of permissions. First, you will receive a pop-up that gives an overview of the permissions that are needed. Please read this and tap OK to continue. When requested to allow the app to access the device's location, please tap while using the app. When requested to allow the app to record audio, please tap while using the app. Finally, you'll be asked to allow the app to find and connect to nearby devices. Tap Allow here. Once you've granted permissions, the app will scan for nearby compatible devices. After a few seconds, you should see a new board appear in the list named STB_PRO. This is your SensorTile.box PRO board. If you do not see your board after a few seconds, tap the double-headed arrows at the bottom of the screen to rescan for known devices. Tap the board name to initiate a connection to it. This will create a Bluetooth connection between the mobile device and the SensorTile.box PRO board. You may be asked to pair the board to your mobile device. If so, please tap the notification to pair. You may need to swipe down from the top of your screen to see the notification if it has disappeared. Confirm the pairing request using the PIN code 123456. At this time, you may be presented with a firmware update screen. If so, please tap the blue Download Update button to update your board to the latest firmware. You'll be taken to the Firmware Update screen. From here, tap the blue Upgrade button. This should only take a couple of minutes while the new firmware is downloaded via the wireless BLE connection. Please feel free to pause this video until the update is complete. After a couple of minutes, you'll be presented with a message that the update has completed. At this time, it is recommended that you restart the STBLE Sensor mobile app. To do so, swipe up from the bottom of your screen, then swipe the STBLE Sensor application off your screen to close it. Then restart the STBLE Sensor app. Once the app is restarted, you should again see your board appear in the list of available devices. The blue LED on your board should be blinking rapidly. Tap the board name to connect to it. Notice that when the STBLE Sensors app connects to the board, the blue LED on the sensor tile will stop blinking and instead turn on steadily. The STBLE Sensors app lets us communicate with the board to see real-time sensor data and modify the behavior of our sensor tile. Let's first look at the default behavior of the sensor tile. Tap the first icon in the list labeled Plot Data. In the drop-down list at the top of the screen, choose Accelerometer. Then tap the play button to the right. You should see real-time accelerometer data being streamed. The three accelerometer axes are shown: X, Y, and Z. Move the board around and see how the data changes. You can also plot gyroscope, magnetometer, and sensor fusion data. Try that now. In the drop-down list, choose Gyroscope. The plot now shows angular velocity for each axis. Finally, choose MEMS Sensor Fusion in the drop-down menu. Sensor Fusion is the default demo active on the sensor tile. In this demo, ST's Motion FX Sensor Fusion algorithm is used to combine raw data from the accelerometer, gyroscope, and magnetometer sensors to create a model for the orientation of the sensor tile in 3D space. This sensor fusion algorithm is running on the sensor tile, not in the STBLE Sensor mobile app. So in addition to streaming the raw accelerometer, gyroscope, and magnetometer data, the sensor tile firmware is also performing a sensor fusion calculation and streaming the results of this in parallel with the sensor raw data. 4 data points are plotted here. These 4 values make up the quaternion, which is the output of the sensor fusion algorithm. Quaternions are often used to mathematically represent device orientation, but they are complex and are not very meaningful to look at in their raw form. So instead, let's go back to the main menu of the STBLE Sensor mobile app. Swipe from the left side of the screen to go back to the main menu. Tap on the MEMS Sensor Fusion icon. The app now displays a 3D model of a 6-sided die, which tracks the movement of the sensor tile. The application is using the quaternions we saw a moment ago to map the sensor tile's actual physical orientation to this virtual model. Try moving your board around in space and see how the die moves. It should track the sensor tile movement closely. Now let's change this functionality by uploading a new application configuration to the board. Go back to the main screen of the mobile application by swiping from the left side. Scroll all the way to the bottom of the list to find the icon labeled Flow. Tap this icon. Here we see groups of predefined configurations. Categories include AI and machine learning core, environmental, etc. Each category shown here contains one or more application configurations that we can upload to our sensor tile. For example, tap the motion category. Here we see several applications that make use of the inertial sensors. Note that each has an upload icon on the right side. Let's try the compass application. Tap on the left side of the compass application box, but don't tap the upload icon yet. We are shown a brief description of the application configuration, as well as a graphical depiction of the demo's main blocks: input, function, and output. For the compass application, we can see that it takes accelerometer, gyroscope, and magnetometer data, sends this data to a sensor fusion algorithm, and streams the output of that sensor fusion algorithm to our mobile app over the Bluetooth connection. We'll come back to these concepts later, but for now we'll use this configuration as is. To upload it to the SensorTile, tap the play icon. On the next screen, tap the upload button to confirm. Wait a few moments for the new application configuration to be transferred. It should only take a few seconds. One thing to note here: the firmware on the SensorTile is not actually being overwritten in this process. Instead, what's happening behind the scenes is a configuration file with the application settings we saw previously, where input, function, and output were defined, is uploaded to the board and is saved to the SD card. The firmware on the SensorTile reads and interprets this file at startup and adjusts its behavior accordingly. Once the upload is complete, tap the Done button. The app will disconnect from the board, and the board will reinitialize using the newly uploaded configuration. The mobile app will automatically rescan for known devices, and you should see your board reappear in the list. Tap on the board once it appears to reconnect to it. Notice how the list of options has changed. Instead of MEMS sensor fusion, we now have an icon for compass. This is because the active configuration has changed. Tap the compass icon. Now we see a familiar compass rose. The virtual compass moves as you move the SensorTile around in space. Each of the predefined entry mode demos available behaves in a similar fashion. Please feel free to come back to this after you have completed the workshop and experiment with them. In the next module, we will cover expert mode, where we will see how to create custom application configurations. In this module, we saw the default configuration of the SensorTile, explored some of the entry mode applications available for use, and programmed our first application configuration to the board. This concludes Module 3.